coming in, have a little chat. Bit of housekeeping. We are recording this session, so of course put your camera off if you don't want us to see your face, and on mute if that's okay while Lizzie's talking. It just kind of gets rid of all the background noise and makes it easier to hear. You can use the chat function as always to put any questions, and Lizzie will answer them either as we go or at the end. We'll try and do both. So if you've got a burning question while Lizzie's going through her presentation, then please do put it into the chat, and we'll aim to answer it straight away. Just to give you a little overview of Tyfu Cymru, I'm sure the majority of you or all of you know by now that once you're signed up to Tyfu Cymru, all the resources and support available is 100% funded. So if there's anything else that you feel that you need support with or advice, agronomy or kind of infrastructure or legislative, then please do get in touch and we can set up either one-to-one or send you the information about webinars that we've got up and coming. My name's Debbie. Hopefully you know me by now, so please do send your feedback to me in terms of what future events you'd like to see as well, because that's really helpful when we're looking at the calendar for the year. So without further ado, we're here for soil health for field vegetable growers. Lizzie Sagoo's Principal Soil Scientist at AHDB and co-author of the AHDB Soil Management Guide for Horticulture, and we're delighted to have her with us. So I'll hand over to you, Lizzie.
Perfect, thank you very much. So just to say hello and welcome to you all. It's great to see everyone, and thank you for Debbie for the invitation to come and talk to you all. Just a bit of background about me. So I'm a soil scientist based out of our Boxworth office near Cambridge, so a little way away from all of you today. I've been with AHDB for almost 18 years now. Sort of my work area covers anything to do with soils, soil quality, soil structure, compaction, those sort of things, and a lot of then also work on nutrient management and organic manures as well. So I've worked on a range of different projects on those topics over the time I've been in AHDB, and I would say over the last 5 or so years that's included projects that are working more on in horticulture and field veg as well, so working with my horticulture colleagues, some of who are here today, Chris and Ewan. So that includes, we did a project a few years ago for AHDB Horticulture looking at precision farming and horticulture, and also particularly a focus on soil quality as part of that project. I've also been involved in RB209, and at the moment we've got a project on crop sensing in field vegetables. So that's sort of a bit of background from me. I've got sort of a presentation today generally looking at the topic of soil health in field veg. Hopefully it's a sort of bits of information that will be of interest to you. I'm hoping it will take about 45 minutes. I might have to speed up as we go through, but we'll see how we get on. Yeah, so in terms of questions, feel free to ask as we go. I'll try and monitor the chat. If I don't pick up on things, Debbie has said that she will monitor that as well and interrupt me if something comes up that's relevant. Right, I'm just going to have a go at sharing my screen. Okay, is that looking good? Perfect. Okay, so first of all, in terms of what we're looking at today, this is what I thought we'd try and cover in the session. So first of all, what is soil health? What do we mean by soil health, the different components of it? Then I wanted to focus a bit on what's a bit different about field veg, what are the specific challenges in terms of managing soils in field vegetable rotations. We can bring in a bit of data that we've got on the current conditions of horticultural soils, which I think nicely highlights the challenges we might face in these rotations. I want to cover a bit on how we can assess soil health. So you're thinking about it on your farm, what can you measure, what can you do on your farm, and then sort of linked into that as we go, trying to think about strategies and things that you can do to improve the condition of soils on your farm. Okay, so soil health is very topical at the moment. It's a bit of a buzzword. I've been working on soils for quite a long time, and I have to admit we only started working with the term soil health about 5 years ago. You know, when I started it, we were talking about soil condition and soil quality, and we did really resist the term soil health for a little while, mainly because the concern with it was, you know, if you ask if your soil's healthy, it's then defining what that means by healthy, and then if it doesn't meet that criteria, does that make it unhealthy? So you know, those were sort of part of our resistance to it. But I think the key thing about it is it seems to have captured people's imaginations, and it's something that engages people. So from that point of view, I think it's very positive, and the increased interest in soil condition, soil health is very, very positive. So I mean, we all want to think that our soils are healthy, and if possible, we want to try and take steps to improve the soil health. So first of all, we can start by thinking, what do we mean by soil health? For me, I think it's useful to think of soil quality and soil sustainability as components of soil health. So soil quality is sort of maybe our fitness for purpose, the state of the soil to deliver a specific function. So for example, you could have a perfectly healthy heathland soil, but it wouldn't be of sufficient quality to grow a good crop of wheat or veg. And then soil sustainability is kind of soil health now and into the future. So the soil might be healthy or in a good condition now, but depending on its resistance to change, it might not be in the future. And the key thing here is the term resilience. It's the resilience of our soil to changes and to shocks, to drought, compaction, etc. And then if we think about our soil, we can divide our soil properties into inherent and dynamic soil properties. So inherent soil properties are the things about our soil that we can't change. So the things we've got to work with. So texture, depth, stoniness, things like that. These are the things that we've got to work with, and they're the backbone of soil quality. And then we have dynamic soil properties, and these are the things that we can influence and manipulate. And I think key factors here for soil health is soil organic matter content and soil structure. And you know, if you think about the properties of soil, quite often we talk about health and the condition of the soil. In our minds, we're kind of thinking about it compared to what it might be naturally. You know, you're thinking about how has your soil changed compared to what it would be if we'd never farmed that land. And you're thinking then of the sort of degrading the soil as from what it would have been naturally. But the challenge also there is if you think about how soils vary, you know, locally and across the country, soils naturally are still very different. So, you know, peats over in East Anglia, very different to, you know, thin stony soils, you know, somewhere else. So, you know, what we're working with is very different to start off with, which is why it makes it challenging then to define or put values on what is a soil in good condition. And then think about what is it we want from our soil? What do we want our soil to do for us? So there are a few different things that we're looking soils to provide for us. So we need soil to provide food and fibre for us, you know, raw materials. Our agricultural land, it's growing crops for us. But we also need our soils to support other ecosystem services, habitats, biodiversity, regulate nutrient cycling as well. And then we've got soils also, we want them to store and cycle nutrients and water, you know, reduce the risk of flooding and store carbon. And then we've kind of also got the cultural and aesthetic value, landscape value of soils as well. So we kind of want quite a bit from our soils. And what's quite nice now from a soil scientist point of view is that these diverse functions of soil is being increasingly recognised. But we are increasingly seeing that our soils are under threat. And in particular, there's sort of three key threats that have been identified in terms of soil condition. So firstly, we've got soil compaction. I think this is an important one to consider, particularly for field veg rotations. So back a few years ago, one of my colleagues, Anne Bogal, reviewed recent data on the structural condition of agricultural soils, looking at studies conducted across various locations across the UK over the last 10 years or so. And that study classed about 40 to 60% of soils in a moderate structural condition, i.e. they had some sort of signs of compaction, with about 30% sort of severely degraded, so severe signs of compaction, so plough pans, signs of surface erosion or gullying. Second key threat is erosion, so loss of soil from the fields. And just the table that you can see there, we've got some sort of typical figures there. So you can see background levels, you know, we'd always get some export of soil particles from the field, but you know, background levels are generally around 0.1 to 0.5 tonnes per hectare per year. But then when we've got cultivated land, that can increase from 0.1 to 10 tonnes per hectare per year. And then when we've got bare soil, that can increase to 10 to 200 tonnes per hectare per year. And if you compare that to the rate that soils form, which is about 1 to 2 tonnes per hectare a year, you can see that we've got a problem, because we don't want to be losing soil at a faster rate than we're building it, because we can't then go on and do that indefinitely. And then linked to that, and kind of linked into both of those, the third threat is the loss of organic matter. And the reason that kind of links the other two is organic matter is quite important to soils in terms of soils that are resilient. So if you've got higher organic matter content, your soil will be more resilient to compaction and more resilient to erosion. And we're seeing that with cultivated land, we're getting a long-term decline in soil organic matter content, and that's of concern as well. And all these threats combined, you know, will result in, they will affect our yields, you know, affect the rooting of the crop, nutrient capture, and increasing sediment and nutrient losses for water. Thinking specifically about challenges, soil management challenges for horticulture, because I think there is something a little bit different in field veg rotations. So I've just pulled up a few pictures here. These are from Andy Richardson from the Allium and Brassica Centre, and he uses these pictures to sort of highlight to him why soil health and soil condition is so important. So on the left-hand side, it's the same field, and the left-hand side there it was a crop of overwintered Savoy cabbage, and they harvested it in poor conditions, and they've been a mess of the field. You can see significant rutting and compaction there. And then that was the following year, it was sprouts. I think they were put in about April time. And Andy said you could definitely see that compaction, the impact of that compaction on the following crop. And the challenge, you know, the thing about horticultural rotations is, you know, and that compaction can be more of a challenge, is the number and frequency of field operations tends to be more. We tend to have more intensive plough-based cultivations, which can weaken soil structure and also contribute to the decline in soil organic matter. And key one is the timing of field operations. So sometimes we're put in a position where we're having to go onto fields when they're wet and the conditions aren't good. This inevitably causes problems with compaction and soil structural damage. And it's not only the fact that these rotations can sometimes tend to create more compaction problems, but also we've got crops that can be more sensitive to compaction. And you can see here, this crop here, you've got a layer of a compacted layer that's really inhibiting the rooting there. So more prone to put compaction in, and we're going crops that are really sensitive to that compaction. And also specific to sort of these rotations as well, it's just this tendency to have more intensive cultivations. And when we plough and we cultivate the soil, we weaken its soil structure. And also every time you turn the soil, you're encouraging oxidation of carbon as well. So where you're regularly working the soil, that's a challenge for maintaining and building soil organic matter content. And then finally, also, you know, soil erosion. Soil erosion is the key risk factors for that is soil texture, slope, but also bare soil. You know, where the soil is bare, the risk of heavy rainfall events creating runoff is much greater. And in some of these rotations, we do have soils that may be left bare for longer, or where you've got a limited crop cover. And sometimes also growing on soil types that are more prone to erosion. I think definitely the worst examples of soil erosion I've seen are with horticultural crops. So I mean, that's a challenge to manage as well. So in terms of sort of soil health and agriculture, it's important to think about how we can manage our soils to keep them healthy, and importantly, to make sure that our activities don't degrade the soil. So I think there are sort of three key components of soil health I want to think about, and these are the ones that I want to focus on today. So we're going to talk a bit about soil organic matter content, because this is really important. Again, do you remember that term resilience? You know, organic. If you can improve and maintain your soil organic matter content, your soil will be more resilient to the other threats. Secondly, maintaining good soil physical structure, and finally, minimising soil erosion. So those are the things I want to go through today. So first of all, looking at soil organic matter. Soil organic matter is a key component of soil health. We kind of explain it as the majority of soil functions are driven by biological processes underpinned by soil organic matter decomposition. So soil organic matter, it underpins everything. It's the energy source for all the soil biology, which then drives nutrient cycling. And then the actions of that soil biology are also extremely important for soil structural aggregation and structural development. And that has implications for how much water the soil can hold as well. So, you know, if you want to look at the condition of your soil, I would say soil analysis for soil organic matter is a key one, and gives a good overall indicator of the condition of your soil. And if you're wanting to monitor change over time, soil organic matter is a key one. In terms of why it's good, I'm sure you'll be familiar with a lot of these things anyway, but if you have a soil and you take steps and you improve your organic matter content, these are the sorts of benefits you'd expect to see. So improving organic matter content, particularly on the lighter soils, we would expect that to help us improve soil structure, water holding capacity and infiltration, improve soil biology, nutrient retention and nutrient cycling. It can help improve water, rooting, nutrient water capture, reduce runoff and erosion, so that's the resilience of the soil. It can help improve productivity, reduce the flood risk, reduce emissions to the environment, etc. So that all combines, it's not only lowering costs but increasing productivity as well. So if we know that organic matter is great. If we want to build the organic matter content of our soil, what can we do? Well, it's all really about increasing your inputs and you're reducing your losses. So we have inputs of organic matter to soil from vegetation, from crop residues, maybe from livestock, manures, etc. So that's how we're adding organic matter to the soil. And then we lose organic matter, we lose carbon. We can lose it when we cultivate as carbon dioxide to the atmosphere. We can lose it also by a runoff, sediment loss to waters. So if we want to build, we need to try and increase those inputs and reduce those losses so we can build slowly over time. In terms of how we do that, if you want a list of measures to improve your organic matter content, you know, the most effective way to build your organic matter content is to convert your land to permanent grassland. But that might not fit very well with your field vegetable rotations. You know, alternatively, rotational grass. Again, I know this is a challenge in a lot of rotations, although I've been interested to see, particularly in the last 5 or so years, the number of horticultural growers that we work with that are now including grass in the rotation specifically to try and improve the soil condition. Applying organic materials, so livestock manures, composts, etc., that can also help build our soil organic matter. Also use of cover crops, green manures, that's that increasing the biomass return to the soil. And then on the other side of it, you know, trying to reduce our losses. I mean, you tell people to try and reduce tillage and reduce soil erosion. So I think we know all these things, you know, but I'm very aware that a lot of them are easier said than done, you know, specifically in our cropping systems. So now, so that's organic matter and the importance of organic matter. So now I wanted to have a think about sort of soil structure, because I flagged this as one that's a particular challenge and relevance in these sorts of rotations. So the soil structure, you know, it's a key component of soil health, and we know that soil compaction can be an important factor limiting crop yields. So good soil structure is really important for optimizing water and nutrient use and sustaining profitable rotations. When we talk about soil structure, what we're kind of talking about it's the arrangement of soil particles and aggregates around which roots grow and air and water move. You can see I've got a diagram there. If we talk about structural stability, it's the resilience of that soil structure. So heavier, and that, you know, there's differences between soil types. So heavier textured clay soils, particularly those with a high calcium carbonate content, so like the soils I've got around near me, calcareous clays, these types of soils are naturally more stable and better structured. Whereas the sands and silt textured soils, they have less natural aggregation and they're more unstable. We have problems with compaction when soil particles are compressed, reducing the spaces between them. And I've already flagged this as one of the major threats to soils. So when you've got compacted soils, there's reduced numbers of large pores, and that reduces how the water can infiltrate into the soil, and it restricts rooting. So soil structure, soil texture is very important here, but also it's the soil moisture content as well, because the strength of the soil is very dependent on the water content of soils, and wet soils are far more susceptible to compaction than dry soils. So the problems we have are when we drive and we cultivate soils when they're wet. That's what causes the problem. So you know, the particular challenges of soil compaction in horticulture rotations are something that AHDB picked up on a few years ago, and we had this project. It was the PF Hort project that looked at, as part of this project, we looked at the condition of horticultural soils across the country. We did a survey of 75 fields. You can see them dotted on the map there. So you can see we didn't come to Wales, but across England and up into Scotland. We went to 75 fields across 49 holdings. We covered a range of field veg and fruit crops as well, annual and perennial crops. And we went in and did a survey of soil structural condition. And on the annual crops, we looked at the condition before they planted the crop and also after they planted the crop. And that was something specifically requested by the growers, because what they were interested in also was how effective were their cultivations before planting on improving soil structure and addressing any compaction issues that they might have had. So what we did, each site that we went out to, we took a comb pentrometer, which is one where you push into the soil and it looks at penetration resistance. We walked W across the field with the penetrometer. You can see in the picture there, Dan's measuring in lettuce, and we looked at penetration resistance to down to 60 centimeters. And then what we did at 20 points, we selected the points of maximum, minimum and medium resistance to do more detailed visual soil assessments. So visual VSA, visual soil assessment, and VES, visual evaluation of soil structure. They're two methods, divine methods we've got to look at the condition of our soils. And we also took bulk density measurements as well. In terms of what we found, these pie charts here show the overall VSA score. So VSA is visual soil assessment. So it's a method of scoring the soil structure for the 47 annual cropping sites from the assessments made prior to planting. So pre-planting on the left, and then again post-planting. So what you can see from that is that pre-planting, so none of the soils scored poorly. So that was a positive. Pre-planting, we had 55% of soils in moderate condition, and then post-planting that was reduced to 42%. So that's positive, because that shows that the condition overall, we've got an overall improvement of condition pre to post-planting. But it's important to say that that wasn't always the case. There were some cases that we saw where cultivation, the cultivations done to put the crop in, either had no effect or had resulted in sometimes quite significant deterioration in the soil structure, which was probably due to the soil being too wet when it was cultivated. So just to give you an example, so here we've got some photos showing how the soil condition changed from pre to post planting at a couple of sites. So the top photos are from a medium textured field growing a brassica vegetable in Lincolnshire. So prior to planting, you see on the left, the soil scored in moderate condition. So what the photos that I've put there, they're part of the visual soil assessment when we dig out a block of soil and then effectively we take it apart with our hands in the field to see how it breaks up. And when you can see on that the left-hand side there, we've got these bigger, blockier aggregates. That's implying a level of compaction, probably from a bit of a cultivation plan, because they've not broken up particularly well. And also some of them are quite angular as well. Whereas then if you move and you look at the picture on the right, which is the condition of the soil post-planting, you can see then we've got quite a fine crumbly structure, which is implying an improvement in the structural condition of the soil after planting. So that's positive. But conversely, at the bottom, another site in also brassica in Lincolnshire, and here prior to planting we had soil that scored in a good condition, but then when we went back post planting, you can see there there's been a deterioration in soil structure. So that those blocky aggregates and that photo there on the right is implying some level of compaction in the soil. So that indicates that we've actually put compaction in when we were putting the crop in. And as part of the scoring that we do, the visual soil assessment, there's a number of indicators we look at, and one of them is the presence of a tillage pan. And this is what these pie charts here show. So what we can see is that before planting, 63% of the fields in annual cropping had a well-developed tillage pan with significant consolidation. Only 29% of soils did not have any tillage plan. Post-planting, the number of sites with a well-developed tillage plan had reduced. So we've gone from 63 to 42% of sites with a well-developed tillage plan. So that's positive. We're seeing an overall improvement. But what I would say is that even post-planting, about 60% of those fields had some level of a tillage plan there. And we've got to remember, again, what I said earlier about these being crops that are susceptible to compaction. So I think for me, that kind of flags a bit of an area of concern. And as part of this work, as well as going out and looking at the soil in these fields, we also spoke to the host farmers about their soil management practices. So what we've got from that is we've got information from the field that we looked at in terms of whether it had a tillage plan or not, and information from the grower on how they managed that field. And this did show us that the cultivations were not always matched to soil conditions or the need for subsoiling. So we've got 30% of the fields were deep tilled where there was a pan, which is good, and 23% of the fields had no pan and didn't use tillage, deep tillage. So I can say for those fields, they got it right, so the soil cultivations were matched to the soil conditions. But we did have 7% of soils that were deep tilled when there wasn't a pan. And that's not great really, because we've said already, cultivations, we should be cultivating for a reason. If we've got compaction, we need to look at removing it, and so cultivation might be necessary, but we should only be cultivating when we need to, because unnecessary cultivations can damage and weaken soil structure. So I would say in 7% of cases there, they've done a cultivation when they didn't need to, and that highlights the importance of looking at soil condition before you go out and you do your cultivations. But we also had 40% that were not deep tilled when there was a pan. So that also flags a concern, because there was compaction in those sites and there wasn't action taken to remediate that. So that I found that really interesting to look at that, and I think it just really highlights the importance of looking at soil structure and trying to match your cultivations with soil structure. And we'll talk a bit later on about how we can look and assess soil structure. So if we want to think about maintaining good soil structure, I mean, the key, and it's again easier said than done, is to avoid or limit soil structural damage in the first place. So ideally, first of all, don't damage soil structure. If we have damaged the soil structure, then we need to look at alleviating it, taking action to try and remove that compaction and improve the condition of the soil. So good soil structure is best maintained by avoid putting compaction in the first place. So ideally, avoid working the soil when it's wet. But I said that's easier said than done. But there are other steps that you can take. So we're seeing many growers now using low ground pressure tyres to reduce contact pressure and reduce compaction. These sort of tyres increase the tyre footprint area, which can improve traction and fuel economy and reduce sort of the degree of compaction. And also the weight of the machinery is an important consideration. And also looking at the footprint of the cultivated area. So restricting loading of soils to the smallest possible area would be a positive step forward, reducing the trafficked area of the field. And this is the principle of controlled traffic farming, which basically aims to try and confine our compacted area to the least possible area of permanent traffic lanes. In its simplest form, it involves greater discipline in the use of routeways and tram lines. I think true controlled traffic farming, can require modifications to machinery, so all are on the same track gauge. But and it can be challenging to implement horticultural rotations, but we are seeing growers that are doing it. And I think that the principles of the controlled traffic farming and actually just taking a bit more care and attention to where we drive and trying to reduce the area that we're driving over, if at all possible, would is a really positive step forward and something that everybody can do. But just to give you an example, as part of the AHDB PF Hort project, we did work with Barfoot's to look at the controlled traffic farming system that they'd adopted on their farm. So I mean, I'm sure most of you are familiar with them. Large vegetable farming business in the south of England and Hampshire, West Sussex and the Isle of Wight. Their crops include sweet corn, asparagus, courgettes, beans, tender stem, rhubarb, squashes, pumpkins and cereals. They started rolling out CTF across their farms about 5 to 10 years ago, and it has been a massive investment for them. And in talking to them, it's interesting because they said the main wake up for them was the realization that they were driving over 100% of the field area. And they were given the statistic that 75% of the compaction can be created in the first machinery pass. And they realized they were creating compaction before they'd even planted the crop. And they said this was their trigger for them to look at what they could do to change their system. And they've adopted CTF because they want to, reduce compaction, improve soil structure, knock-on benefits to crop yields. They also want to, reducing costs is another one, reducing the costs of cultivation and reduction in inputs as well. And just to show you what that looks like, I know this is very little on the screen, so hopefully you can see that. But what we've got there, all those dots represent tyre vehicle wheelings, and what we've got on the left, it's all the wheelings before they adopted the CTF system. And as you go down, you've got all the different machinery operations in the field. So you've got the plough, the harrow, and the fertilizer spreader, laying the plastic, etc., all the way through. And what they could see is that when they put that all together, they were driving over more than 100% of the soil. So every part of that field was driven over. So then what they tried to do is they moved over to CTF, and what we've got on the right is their CTF system. And what you can see here is the tracking all nicely matches up. And over the course of the rotation, then they've managed to reduce their traffic area to 37%. So in order to try and do this, they did a few things. They moved away from the plough. They made modifications to equipment to everything is now on a 5 metre working width. So they either bought new or they modified existing. I think they bought a new drill, which also lays the plastic, so it cuts out an operation. and a few other things in order to try and fit in that system. But so I mean that as an example, that's obviously quite a big scale one. It was a massive investment on their part. But I think those two diagrams are quite nice because it really nicely illustrates when you put all your operations together how we can be driving over all of our fields. And if even if you can't go to a true CTF, it's just a case of thinking about how we drive over our fields, and if possible, like trying to line up the wheelings a bit more. And actually, quite a few years ago, when we had one of the project meetings for this project, we had Tim Chayman. Some of you might know him. He does a lot of work on CTF, and we had someone else in the room that was saying that CTF wouldn't work on the farm. It's all great, but until you get the contractors in, they're just going to drive their trailer right across the field. And Tim sort of pulled them up and said, well, you've got to tell them they can't do that. They need to respect the wheelings. They need to operate in a specific way. So part of it is a mindset as well. So thinking about, ideally avoid putting compaction in. I'm sure none of us would compact our soils like, none of us are going to try to take actions to willingly damage our soils. And I think particularly in these sorts of rotations, there are circumstances where we will invariably damage the soil structure. So if we do create compaction, then I think we need to take steps then to look at alleviating compaction, because, particularly where we're growing crops that are susceptible to compaction. So the first thing is to actually look at the soils and assess the extent and depth of compaction before you do any operations. And then when you look at the operation, cultivations, subsoiling should only be carried out when the soil at working depth is in a dry and friable condition, so that it will shatter rather than spear. This is where we can get damage from subsoiling when the soil isn't at the right conditions. And the general advice is to target the depth of cultivation about 25 to 50 millimetres below the base of the compacted layer. This is where it's important to go out, dig a hole, try and work out where your problem layer is, and then set your working depth just below that and go in at the right time. I also just wanted to touch on, I mentioned soil erosion at the beginning and how this can be a challenge for these crops. We can get soil erosion by wind or by water. It is a natural process, but we can accelerate it significantly by our farming operations. I've already flagged up the table there on sort of typical of different levels of soil erosion. The key problem is soil erosion by water, wherever particular problems with sands and silty soils more prone to erosion, particularly when they're bare, and then we have prolonged periods of heavy rainfall. If you've got a problem with soil erosion, I think it's really important to try and take steps to rectify that. And that might be a series of measures. If you've got severe issues of soil erosion, it might be you need to take specific measures in those fields, maybe looking at buffer strips, changing the way you plant, etc. And there is quite a good a screenshot of an AHDB case study there on managing soil erosion in asparagus production. That was a case study that AHDB did with the chins, and they had significant challenges with soil erosion. If you think about asparagus, a lot of the soil is left bare, and they were on these sort of higher risk soils, sloping soils, and it gives you an example of the range of different types of measures you can take within fields to try and reduce soil erosion. And then along with that, as I said at the beginning, building soil organic matter and increasing your soil's resilience to erosion. So now I wanted to think a bit about how we talked about different components of soil health, the benefits of organic matter, issues of soil structure, and problems with erosion. But I want to think now about how we can assess the condition of our soils. So what can you do on your farm or in your fields to try and get a measure of the condition of your soil, and also thinking about what you can practically measure, but then how you benchmark those values as well. I think the important thing to realise is, there isn't one indicator of soil health. When people say, what can we do to measure soil health? There's not one measure that you can take that will encompass everything that we've talked about. You know, soil health, we can kind of divide it into, you know, soil biology, soil chemistry, and soil physics. So if we want to look at the overall condition of our soil, we need to look at some indicators that kind of encompass all three of those. And the other thing is thinking about when we sample as well. And the general guidance is, you know, we'd say to sample on a rotational basis at a similar time from the same location in the field. So another AHDB project some of you might be familiar with, the Soil Biology and Health Partnership. It's been going now for a few years. It's due to come to an end this year. This project did a lot of work on trying to develop soil health, measures of soil health, and has tried to develop those into a scorecard approach. So to look at indicators that growers can practically measure on farm and then to benchmark that. So as part of the project, they came up with a huge range of different measures of soil condition, and they reviewed them all and looked at the sort of information we've got in order to help growers benchmark against those. And they basically came down to sort of these key measures of soil health, which you can see in this table here. And we've got the physical indicators, so things like visual soil assessments. We've got the VES there, penetration, resistance, and bulk density. Got our chemical indicators. This is where we take a sample and send it to the lab, so pH, routine nutrients, and soil organic matter. And then we've got our biological indicators. So here they flagged earthworms, respiration, and microbial biomass. Now the ones that are highlighted there, highlighted bold, so VES, soil analysis for pH, routine nutrients, and soil organic matter, and earthworms. These ones are, I think, the key ones that will feature in the scorecard, because one, they are something that you can do on your own farm that covers physical, chemical, and biological health. And also these are the ones where we have the most robust benchmarking figures to compare against. So I think these are good things for you. If you're thinking about what you can look at, take a soil sample, get it analysed for your routine analysis, pH, pK, magnesium, include a soil organic matter content as well. But as well as taking your sample and getting analysed, also look to do some sort of visual soil assessment and do an earthworm count as well. So we've flagged VES there. I don't know whether any of you have come across this before. It's been developed by SRUC, and if you Google visual evaluation of soil structure, you will find this scorecard that you can download and print out. And this is just, it's a way of assessing your soil structure. I think if you haven't seen this before and putting up like this, it might look a bit intimidating, but what I'd say is this is really easy to do. I mean, they let me do it and I don't get out much, so any of you can do this. And what's particularly nice about this is, I mean, you don't even have to worry too much about putting a score on it, but it gives you a guide for the sorts of things you should be looking at when you assess your soil structure. Basically, you go out into your field and take a spade and dig out a spit of soil. So you might have a 20 or 25 centimetre spade, dig round 4 corners, lift it out, and then basically you're breaking it down and you're breaking it apart. And as you break it apart, if you the information on this card helps you for the things you should be looking at, and you're looking at how easily it breaks apart, how hard the aggregates are. So when you pick up an aggregate, can you does it crumble in your hand? The size and shape of the aggregates as well. So where they're more angular, that's an indication of compaction. And then if you have sort of slightly blockier or harder aggregates, once you've tried to break them down with your hand, I would then snap them apart to look to see whether you've got roots growing through them as well. And once you start doing this, you tune in very quickly to differences in the soil, so, and it sometimes can be used within a field, maybe to go to a slightly more compacted area and then an area that isn't so compacted, and you will see differences immediately. And it's a really good way to look at your soils. The one thing to note is you should be looking to do this when your soils are moist but not saturated. If you try and do it when it's dry, particularly with heavier clay soils, that when they dry, it's difficult to do it, because you can almost think that you've got compaction, the aggregates become harder, you know, clays bake. So you need to try and do it when it's moist. It's the sort of thing that we're doing a lot of at the moment, this time of year. It's a good time to get out and have a look. And if you want, I mean, you could just use this as a general guide for looking at your soils, but you can score them as well. So this gives information on scoring from sort of 1 to 5. And we'd say 1 to do is good. And then when you start getting into 3, 4 or 5, that's kind of a bit of a flag for maybe you need to look at things. And when you do VES as well, you can also look at earthworms at the same time. So quite often when we're doing soil assessments, we'll do the VES, but then we'll also count earthworms on the same block of soil that we've dug out. So if you take a tray or a bit of plastic out that you can dig out that block of soil on, put it on the tray or the bit of plastic, you can break it apart, and then you can look at earthworms in that block of soil as well. Yeah, and the general standard is to count all the worms from a 20 centimetre cubed block of soil in 5 minutes. We put a time limit on because sometimes, you know, if you spend ages on it, you can pull out more earthworms. So standardise that for 5 minutes. And then we've got this guidance here sort of to benchmark that. So different values for arable and grass, because obviously you get a lot more worms in grass, and it just enables you to kind of benchmark what you're finding on your farm to compare to sort of what's sort of typical or average. And so AHDB, as part of this soil biology and health project, they're developing this soil health scorecard that for these indicators kind of give you a different sort of traffic light system as such. So this is almost ready, and it should be up on their Great Soils website later this year. And this is just wanted to give you an idea of what it kind of looks like. And I think this sort of approach is quite useful to give an overview of the condition of the soils on your fields. So this is just an example from one field that we looked at as part of this project. You can see there we've measured soil organic matter, pH, PK magnesium, we've done a VES, we've also taken a bulk density sample and earthworms. So if you look down that list, you could do all of those on your farm. You might not do bulk density because you need bulk density tins for that. But everything else that's there is something that you can measure from your fields. It then gives you the benchmark, the threshold values to compare against. And we've color coded those into sort of a traffic light system. The thing that my colleague Anne, who was heavily involved with this, would flag is that if it's red, it doesn't mean it's bad. It's just a flag to investigate further. So if you get something that's highlighted as red, you know, it's just a trigger to you, maybe to go out and have a look, investigate a bit further, look at that field in a bit more detail, and then maybe consider if you need to take action in the future. So what we can see with this particular field, it was one field, and we looked at 3 different zones, and you know, the ones that stand out is there's an indication of compaction there, because particularly in zones 2 and 3, we're scoring a 4 for the VES, and we've also got lower than average earthworms. And just to sort of show you what the soil looked like, so that picture I've just put up there is a picture we took as part of the visual evaluation of soil structure, and you can see that sort of blocky sort of soil structure. So there was some compaction in that field. So I mean, I quite like that approach, and I'd say look out for that on the AHDB website, because it's something that you can definitely all look at in your fields. Okay, so sort of rattle through those slides in terms of what are the key messages, what were flagged. So yeah, thinking about soil health overall, you know, it's we need to think about an integrated approach, and we need to think, you know, it's chemistry, physics, biology. It's more than just taking our soil sample and sending it to the lab. But I think that combination of soil sample, a visual soil assessment, and counting of earthworms gives us a really nice overview of 3 components. Also, the thing with soils is it's not just about, it's great to get people more interested in soils. It's great for you to be looking at soil condition on your farm. Also think of it about it's a long-term thing. So really, you know, doing measurements now and then repeating them every couple of years. And we often advise that taking measurements at the same point in the rotation from the same location. And if that's something you start now and then you're doing every few years, you'll start to build up a really good picture on your farm. It's something in particular I would encourage if you were thinking about making a management change. You know, if you're thinking about changing something with a specific aim, you know, maybe to try and improve soils, it's great to get baseline values in there to start off with, so you can monitor change over time. So look out for the scorecard approach, because I think that's something that hopefully will be useful to you. We've covered different aspects of what we can do to try and improve our soil health. I mean, the key ones I picked up on there: steps to improve, maintain and improve soil organic matter, in particular focus on soil structure as well. And try, if you're going out and you're looking at soil structure, try and link those visual assessments to current soil management practices. So finally, I've just tried to flag a couple of other sources of information for you. So I think the AHDB Great Soils pages, if you just Google AHDB Great Soils, there's a lot of resources there that's of use. A couple that I've flagged up there. So there's a soil management guide for horticulture that we wrote a few years ago. That's got quite a bit of information on assessing soils and soil compaction, etc. There also, if you've got a problem with soil erosion, the case study on asparagus is quite a nice one to look at, because it looks specifically at in-field options that they've done there. Other documents that are quite useful. The EA produced a guide called Think Soils, which has a lot of pictures there to help you look at soil structure, and the SRUC visual evaluation of soil structure guide as well. Those are all resources that are on the internet, and if you Google them, you'll find them and be able to download them. And I think that's me finished. So I might stop sharing my screen now so I can see you.
Thanks, Lizzie.
Thanks.
There's a question come through in the chat box. You can probably pick that up yourself there.
Yeah, what is the range of soil organic matter that you see in veg cropping, and what cropping regime gives the best outcomes for soil organic matter? That's a really difficult one to answer. I did have a slide on organic matter that I should have put in. In terms of typical organic matter levels, the key, it varies depending on rainfall and texture. So and the key factor there is texture. So the heavier textured soils tend to have hold more organic matter, and wetter areas hold more organic matter. So what I would recommend is having try and, when the AHDB scorecard is published, go and find that, because that's got threshold values for different clay contents of the soils and different rainfall areas as well. But it's challenged to give a typical value. What that does is that will give you average values for different textures and different rainfall areas, and it flags them whether you're below those. In terms of what cropping regime gives the best outcomes for soil organic matter, I mean, grass rotations, cropping where if you've got a perennial cropping that you're not cultivating the soil as much, that improves soil organic matter. So it's the challenge is rotations where you've not got as much organic matter inputs and you're frequently cultivating the soils. That's where it's hard, and on lighter soils it's harder to build the soil organic matter content up. So it comes back to trying to build soil organic matter by increasing your inputs of organic matter and trying to reduce, if you can, take steps to reduce the level of cultivation where that's feasible and possible within your rotation. Okay, so I can see a question from James. Any thoughts on the introduction of mycorrhizal fungus to improve soil or plant health? That's not something that I've worked on, so I wouldn't want to comment on that. There are a range of, well, I will say that there are a range of products being marketed, some of them with quite fantastic claims, and I would say to you that if something sounds too good to be true, it probably is. And I would want to be seeing, if someone's making claims for a product, asked to see the evidence on which that is based. I think we know the basic principles of good soil management. I think that should form the basis if you're trying to improve your soil condition. Question from Anne. Do you find that organic systems score better on soil health than conventional ones? I haven't got any, I'm sure there is data to support that. I can't pick up anything off the top of my head. I would say that I could imagine that might be the case because in organic rotations, there's a particular focus on building fertility. And we do that through rotations and through cover crops and from legumes in order to build the nutrients, because we can't get them from other sources. And those are all things, we're building our nutrients by adding organic matter. So those are all things that will be beneficial for soil health. Christina, concerned about herbicides in manures. Several market gardeners have had damage or losses. Do you have any advice regarding this? It's not something, it's not, we've had the same question asked previously. And again, it's not a problem I've personally encountered at all. And we've done a lot of work on manures. Quite often we find that manures aren't used as much in fresh produce because of restrictions on, bio restrictions. So quite often you're seeing other materials, composts and digestate used as well. So I'm struggling to answer a bit more than that. As I said, we've done a lot of work on manures, and I think that in terms of improving soil quality and supplying nutrients, I think it's a very useful way of building your soil organic matter and your nutrient content.
Anyone else have a burning question that they would like answered now? It was really comprehensive, actually. Thank you, Lizzie. And the visuals are really helpful, I think, in terms of knowing what it is that you're looking for.
Yeah. From Anne, as the cap will be replaced by a different policy. And what do you mean by NML? Public money for public goods. Do you think soil health will feature more in future policy? Yes, I think it will. I think it's a really difficult one. And lots of interest, lots of discussion as well at the moment about carbon credits, and farmers being paid to store carbon in their soils. And also, and then if you're going to do that, measuring it over time, I think it's really tricky. One question comes down to actually being able to measure carbon sequestration accurately enough in order to be able to be paid based on it. Just to sort of put it into context. If you think about your fields, most of the fields that I've come across are pretty variable, anyway. And we've got a couple of examples of fields where we've gone into and we've done very detailed nutrient mapping, including organic matter, where we might have sampled them on a grid basis or a hectare basis. And what that immediately flags up to me is that the underlying variability in carbon organic matter content across most fields is probably almost always going to be larger than the change we're trying to measure. So then it's it's really challenging to get to accurately measure the change in organic matter content confidently enough to be able to be paid on it over time. So you could see a case where you could go in on different corners of your field and walk a W and potentially get a very slightly different result. And actually we're now starting to come around to, if we're wanting to measure change over time, using a point sampling approach, particularly for carbon, where we GPS locate a point and take a number of cores from around that point. So when we come back in 3 or 4 years time, we can go to that exact same point. The other comment I would have in terms of that and carbon is that it goes both ways. You can, if you turn around and put a field down to grass, particularly a lighter field, I'm sure you can measure a change, an increase in organic matter content over a few years. But then if you plough that out and change your cropping, it will go back. It will go back the other way. I personally sometimes get a bit frustrated about it because it's not something. Some people are seeing it as almost like a get out of jail free card, where they can reduce the need to make other changes to reduce emissions by thinking we just store it in the soil. I would say that the steps to improve the carbon and organic matter content of our soil are positive, are very positive for ourselves and our soil quality and our crop production, and we should be looking at it for those reasons. But yeah, DEFRA are very interested, and I think it's going to be, it'll be interesting to see how things go. I think payment by measurement is going to be really challenging, and I think it's more likely, and I would be happy with payment for actions, and actions that we know improve soil quality, rather than trying to reward based on a measurement. Alison's asked, I'd be interested in your views on manure, sheep, horse and cow digestate. Okay, so we've done quite a lot of work on manures. When I started at ADAS, most of my time was spent looking at on projects looking at managing manures. We've done work also that's looked at manures and soil quality, and we know that repeated applications of organic manures over time can have a positive impact on soil quality, and that actually it's probably one of the quickest ways of building soil organic matter in arable rotations. We also know that organic materials vary, and if you're wanting to improve sort of soil quality and build organic manures, you really need to be looking at bulky organic materials with like solid manures, composts, things like that. Slurries and digestates, they're generally 95% or plus water, so you're not putting on as much organic matter. I think the digestate, digestate and slurry, I would view more, for its nutrient content. It's a fertilizer. It's a digestate is a liquid nitrogen fertilizer. It's going to have limited impacts on soil quality, but can be a very valuable source of nutrients. So all manures, all organic materials, good source of nutrients, and the solid organic materials, good source of organic matter as well. I can see Anne's also flagged Patrick Holden's doing some interesting work on this. Thank you. Any other questions? Feel free to unmute if you want to chip in with any other comments, or if there's any sort of specific challenges that you've found on your farms. Yeah, Jeremy, is destoning a serious risk to soil health? It's a significant cultivation or movement of soil, and so from that point of view, these big cultivations, you're encouraging oxidation of you're encouraging oxidation of carbon, so it helps burn organic matter, and also, as I said earlier on, that all cultivations can damage natural soil structure, and if you go through and destone, you're kind of taking out any natural soil structure. So yes, it's a challenge, but then, as with all of these things, we do them for a reason. So I wouldn't want to say, you don't want to sit and say this is bad or you can't do it, but it's recognizing the things that we do, or the parts of the rotation that we've got where there's more challenges, and if we can't make changes there, trying to then make changes in other parts of the rotation to try and improve things there. It's a balancing act. We're farming this land for food. It's sometimes compromises need to be made.
Well, I think we've come to a natural end. So before we leave, thank you, Lizzie, very much. That was really helpful, I'm sure. Last question from Nick has come in. Thanks, Nick.
Just need to read that. So the Wales-wide white paper on the future of funding Wales has just been released. Some of you have already seen it. Soil health is one of the key factors that we looked at with regards to future payments. Very interested to see how this will be measured. Yes, so am I. Ultimately, will the public be prepared to pay a higher price for produce being grown on more sustainable soils as opposed to the cheap nitrogen heavy produce we've all got to come to take for granted? Yeah, very good point. I think it's a very interesting area to work in. Lots of interesting discussion coming on, and I think there's sometimes sometimes there aren't easy answers. So particularly from a soil science point of view, where we sit and we hear people talking about paying farmers for improving the soil quality, and particularly paying farmers to measure carbon, we sit there and think, well, how are you actually practically going to do that. So it will be interesting to see how things go. But it's all very, you know, this increased interest in soil health and soil condition and valuing the importance of soil is all, you know, very positive. And you should hopefully help support growers in terms of improving overall soil quality and support their production as well. You know, so hopefully win-wins for everyone.
Sarah from Tyfu Cymru has just put into the chat there, if you wouldn't mind completing the survey, please, that would be really helpful. It means that we can continue to put on sessions that are led by you as a sector, so they're really helpful. If you can complete that, that's great, thank you. I'm aware we're slightly over time, so I'm going to call this webinar to an end. Thank you all very much for attending. It's really good to see some new faces and some familiar faces too. So thanks very much, everybody, and look forward to seeing you at the next webinar.